Howdy, y'all. This is chapter 5, section 6, equations of quadratic functions from their graphs. So in order to use a quadratic function as a mathematical model for something in the real world, you're going to need to be able to identify the quadratic function given only certain points. So that's what we're going to do in this section. For a linear function, you need 2 points in order to write an equation. And for quadratic, it turns out you need 3 ordered pairs. So for this first example, we're going to have the ordered pairs, let's see, -2, -11, and 4, 13, and finally 6, 29. So first thing we're going to do is we're going to look at just what the general form of a quadratic equation is, and that's going to be y equals ax squared plus bx plus c. So now we're just going to plug in all 3 of the ordered pairs into this general form. So the first one, we're going to have -11 equals a times -2 squared plus b times -2 plus c. And then we can transform this again and say -11 equals +4a minus 2b plus c. And if you do a similar thing for these 2 points, you just got to plug in 4 for x, 13 for y, and then 6 for x, and 29 for y. You're going to get the other 2 equations. 13 equals 16a plus 4b plus c. And then 29 equals 36a plus 6b plus c. So now we're left with these 3 equations. Now we can solve for all 3 variables using linear combination like we did a couple chapters ago. So the first thing that we're going to want to do is we're going to want to pick 2 equations to eliminate a variable. In these situations, c is always going to be a constant, so that's always going to be the easiest variable to eliminate. So what you're going to want to do is take the first 2 equations, so we'll go like this, and we're going to subtract one from the other. So we're going to just so the math's a bit or the arithmetic's a bit easier. We're going to subtract this first equation from the second equation. So 16a minus 4a is going to give us 12a. Then 4b minus -2b is going to get us positive 6b. The positive c minus c, that's going to cancel the c, and then we're going to have 13 minus -11, that's going to get us positive 24. Now we can do a similar thing for these 2 equations, and we're just going to subtract this second equation from the first equation. So 36a minus 16a, that's going to give us 20a. Then 6b minus 4b, that'll get us positive 2b. And then 29 minus 13 is going to get us 16. Now we're left with 2 equations and 2 unknowns. So what we're going to want to do is, we have some like terms here, so we might be able to just eliminate b easily. So let's see. There is a common term, or common factor of 6 in the first equation, so we can factor out the 6 and rewrite that as 2a plus b equals 6. And then, whoops, that's not right, equals 4. Undo that. How do I undo that? Yeah, 4. And then looks like we can factor out a 2 right here, and then it'll get us 10a plus b equals 8. Now, we can do another linear combination right here. Just so the arithmetic's a bit easier, we'll subtract this equation from this one. So 10a minus 2a is going to give us 8a. b minus b, that's going to cancel the b's. And then 8 minus 4 is going to equal 4. So that means that a equals 1/2. Once we know that a equals 1/2, we can substitute it into really any of these four equations and solve for b. So I'm going to pick 2a plus b equals 4. That's just going to make it pretty easy arithmetic. So we're going to substitute it in for a, so 2 times 1/2 plus b equals 4. So 2 times 1/2, that just becomes 1 plus b equals 4, and therefore b equals 3. Now we solve for b and we solve for a, so we can pick any of these three equations and solve for c. So I'm just going to pick the first equation and say 4 times 1/2 minus 2 times 3 plus c equals -11. So this becomes 2 minus 6 plus c equals -11, or c equals -7. So now that we solve for all three variables, we can plug them all back into the original equation, which is y equals ax squared plus bx plus c, and say that the function that has those three original points is 1/2 x squared plus 3x minus 7. Okay, so now we have three new points, but this one is going to be a lot easier than the last problem. So let's first plug in the point 0, 5 into the general form y equals ax squared plus bx plus c. So that's going to be 5 equals a times 0 squared plus b times 0 squared plus c. So the a and b are going to cancel out because of the 0. So just we know that c equals 5. A lot easier. Okay, now we can plug the second point in. 13 equals a times 2 squared plus b times 2. I don't know why I put the parentheses there, but that's okay. Plus c. And, oh, whoops, but we know that c equals 5. So we can just put 5 right there. And we can do this, and then multiplying this out a little bit, we'll say 13 equals 4a plus 2b plus 5. And we can do a similar thing with the point 326, and that's just going to give us 26 equals 9a plus 3b plus 5. So the next thing we're going to want to do is simplify these equations a little bit. So let's first combine the like terms. We can move the 5 over, and we're going to say 8 equals 4a plus 2b. And then for this one, we can move the 5 over, and we'll say that 21 equals 9a plus 3b. Now we have some common factors in both equations that we can divide out to make it even easier. So for this first equation, we can divide out a 2, and we can say that 8 divided by 2 equals 4, and that equals, and 4 divided by 2 is 2a plus b. And then for the second equation, we can divide out a 3, and we'll say that 7 equals 3a plus b. Now it's pretty easy to linearly combine these two equations, and we can do that in order to make the arithmetic easier. We'll subtract the first equation from the second equation. So 7 minus 4 equals 3. 3a minus 2a is just 1a. And then b's cancel, so a equals 3. So now we can just substitute this right back into either equation. We'll do the first. So we'll say 4 equals 2 times 3 plus b. And then that means that b equals -2. And then recall earlier we found out that c equals 5, so the equation for this quadratic function is going to be y equals 3x squared minus 2x plus 5. Okay, this is the last example, and this one's a little bit different in that we're given the vertex and a point on the parabola. So let's recall the vertex form of of a parabola, the general equation that is y minus k equals a times x minus h, where the vertex is the point hk. So that means we can substitute in the -5 and 2 into that for the vertex. So y points at -5, so we're going to say y plus 5 equals a times x minus 2. Now all we need to do is find a. But we can do that if we plug in this extra point, 3, 1, into in for x and y. So we'll say 1 plus 5 equals a times 3 minus 2. So this is 6 equals a. That's a 1. So that means the general form for this equation is y plus 5 equals 6 times x minus 2. And you can multiply that out and get that into standard form. Y equals ax squared plus bx plus c. Oh, just realized I forgot one important thing. This should be squared. Or otherwise it would be a linear equation squared. There we go. Also squared. Okay. See you later.